They found it in the soft light of an autumn morning in 1944, an American patrol rounding a bend on a rural French road, expecting another ambush, another burned-out wreck, another reminder of how costly each mile had become. Instead, they met silence. And in that silence stood a Panther tank, perfectly still, its hull unscarred, its armor untouched by fire or fragmentation. For men accustomed to seeing German steel only in ruin or in motion, the sight felt unsettling, almost theatrical, as if the battlefield itself had paused to draw their attention to a single, unresolved question. Up close, the contradiction sharpened. The Panther was everything Allied reports had warned of. A long 75mm gun that promised reach and precision, armor arranged in sharp, sloping planes that defeated rounds the way a glacier sheds rain, and a silhouette that looked less like a machine and more like a poised animal measuring its next move. Yet inside, the hatches hung open, the radios were intact, and there were no bodies, no signs of struggle, only absence. A tank built to dominate had been abandoned quietly, almost respectfully, by the men who had trusted it with their lives. When the engineers from the U.S. Ordnance Department arrived, they circled the machine with methodical curiosity. They noted the pristine suspension, the unblemished mantlet, the immaculate state of the main gun. Nothing suggested catastrophic failure. Nothing suggested panic. And yet, something had compelled the German crew to step away from their greatest advantage, leaving behind a weapon the Allies had spent 2 years learning to fear. Intelligence officers made their decision quickly. The Panther would be shipped across the Channel, then across the Atlantic, to a proving ground where its secrets could be studied bolt by bolt. Strength, after all, is never fully understood until examined in stillness. What they did not yet realize was that this immaculate relic would soon expose a truth far more complicated than its reputation, one that would reshape how the Allies understood German armor entirely. By the autumn of 1944, the Panther's reputation had already outgrown the machine itself. It was spoken of in mess tents and briefing rooms with the same guarded tone reserved for storms or plagues. Things that arrived suddenly, reshaped the battlefield, and left little room for error. Its origin traced back to the shock of 1941, when German crews first confronted the Soviet T and realized that their own armored doctrine had been overtaken by a new geometry of war. The Panther had been conceived as the answer, a tank meant not merely to match the T-34, but to surpass it in every measurable way. And in Allied imagination, it had done exactly that. Yet as American officers walked around the captured specimen, that imagination began to loosen. They knew the gun could penetrate a Sherman from distances that often felt unfair, and they knew the sloped armor rendered standard rounds ineffective unless fired from perilous range. But beyond those battlefield impressions lay a fog of uncertainty. Reports from the front whispered of catastrophic breakdowns, of drivetrains that seized without warning, of tanks abandoned after only a handful of miles. The officers understood fear well enough. What they lacked was clarity. Washington's orders were therefore blunt: strip the myth to its core. Determine whether the Panther was truly the war-winning marvel German propaganda claimed, or merely the fragile triumph of a desperate industry. Engineers began preparing test plans with the precision of surgeons. Mobility trials on broken ground, armor assessments measured in millimeters and degrees, drivetrain analysis under controlled strain, and a full ballistic study of the long-barreled 75. Nothing would be assumed. Everything would be verified. Soldiers passing the tank reacted first to its presence. Its lines were predatory, its stance confident, its very shape suggesting inevitability. But the mechanics, kneeling beneath its hull plates and tracing the pathways of cables and gears, saw another story. They noted the complexity that lurked beneath the metal, a machine that demanded not only resources, but finesse, time, and perfect conditions. Beauty and burden welded together. In the end, the Panther stood before them as a contradiction. A symbol of German ambition, engineered to be lethal, yet shadowed by a fragility that no amount of paint or propaganda could conceal. And as the first tools were lifted to begin the examination, a quiet question settled over the proving ground, a question the next tests would answer with unmistakable clarity. The Panther's first awakening on American soil came at Aberdeen Proving Ground, where long concrete lanes met open fields designed to expose every strength, and every flaw of the machines brought there for judgment. Mechanics tightened the last bolts, drivers settled into unfamiliar seats, and officers gathered at a cautious distance. See, when the ignition switched on, the Maybach HL-230 answered with a deep, resonant roar. a sound that rolled across the proving ground like the opening note of a long-studied symphony. Slowly, then with growing confidence, the tank began to move. On the initial run, the Panther surprised even the seasoned observers. It accelerated with a smoothness uncommon in wartime armor, its weight distributed across the interleaved road wheels that had become its most recognizable signature. Across uneven ground, the suspension absorbed each rise and hollow with an almost unsettling grace. Dust rose behind it in a wide, even plume, suggesting balance rather than brute force. For a moment, the machine lived up to its legend, a predator built to glide rather than stumble. Inside the turret, American test drivers examined the sights that German crews had relied upon. The optics, built with the precision of a watchmaker's discipline, offered clarity the Sherman could not match. Even in motion, the gun retained a steadiness that hinted at the kind of accuracy Allied crews had learned to fear in Normandy. Here, the Panther felt not experimental but refined, the product of a nation still willing to lavish time and skill on complex instruments of war. Yet beneath the early admiration ran a quieter current of concern. Mechanics trailing the tank began noticing a sharp rise in temperature around the final drive housing, heat radiating through steel panels that should have remained far cooler at such low speed. When the tank halted, gloved hands hovered near the casing and pulled back almost immediately. Something within was laboring harder than it should. As the Panther resumed its path, engineers recorded faint but persistent vibrations near the drive sprocket, small tremors that had no place in a machine of this caliber. They were not enough to halt the test, not enough to justify a verdict, but they were unmistakable. Warnings whispered in metal. For now, the tank still moved with confidence. But those who watched knew that in war, the first failures rarely announced themselves loudly. And as the Panther rolled into its next trial, the question lingered like a tightening thread. How long could such elegance endure? Long before the Panther rolled onto American soil, it had already secured a place in German military lore. In captured documents, factory memoranda, field reports, and internal assessments, its image emerged with unmistakable confidence. German engineers described it not as an evolution, but as a culmination, a tank shaped by lessons bought in blood on the Eastern Front and refined into what they believed was the pinnacle of battlefield engineering. The tone was consistent and unwavering. The Panther would restore the balance that Barbarossa had unsettled. It would become the instrument through which technical mastery would reclaim strategic certainty. American analysts, sifting through these papers in dimly lit rooms, recognized a pattern that bordered on hubris. The language spoke of inevitability, of superiority measured not in divisions or fuel reserves, but in millimeters of armor and meters per second. For a Reich fighting a war of attrition it could no longer win, this belief held extraordinary weight. If numbers could not be matched, then precision would have to compensate. The Panther became not merely a tank, but a philosophy, an assertion that brilliance could replace breadth, and craftsmanship could substitute for mass production. Its strongest argument lay in its armor. The sharply sloped glacis plate, angled at 55 degrees, was a direct and deliberate reply to the lessons of 1941, when German crews first confronted the T-34's revolutionary contours. The design transformed effective thickness, forcing incoming rounds to ricochet or lose their penetrative power before striking the steel beneath. That simple shift in geometry marked a turning point in armored warfare, and even the American engineers studying the captured vehicle acknowledged the elegance of the solution. Here, German innovation had been not only clever but prophetic. Yet as the tests continued, admiration gave way to unease. For every stroke of brilliance, there were two traces of overreach. The interleaved road wheels, while offering remarkable stability, demanded maintenance routines incompatible with the realities of a collapsing front. The engine compartment packed power and promise into a space so confined that overheating seemed inevitable. And across the vehicle, crews found mechanisms whose precision depended on conditions Germany could no longer guarantee: skilled labor, abundant materials, and the luxury of time. The American testers saw what the documents never admitted, that the Panther's greatest weakness had been forged at the drafting table. Complexity replaced simplicity at every turn, not because the battlefield required it, but because German doctrine had come to believe that excellence must always express itself through intrigue. What looked like superiority in blueprints, often translated to fragility under fire. In the end, the seeds of the Panther's downfall lay not in the mud of Normandy or the snows of the Eastern Front, but in the very principles that guided its creation, principles that assumed mastery could be engineered rather than sustained. And as the test program advanced toward harsher trials, those assumptions were about to meet forces they could not negotiate. The first artillery trials at Aberdeen began under a clear sky, the Panther positioned at the far end of the range like a contestant awaiting judgment. When the crew loaded the KWK-42 and aligned the long barrel toward the distant target frames, even the most skeptical observers watched with quiet anticipation. The gun fired with a sharp, disciplined crack, its recoil absorbed cleanly by the massive mantlet. Shot after shot struck with remarkable precision. At 1,000 meters, dispersion was minimal. At 2,000, the impacts remained tightly grouped. The engineers recorded muzzle velocities exceeding 900 meters per second, figures that confirmed why Allied tank crews spoke of the Panther with a respect tinged by unease. Here was a weapon that did not merely project force, it delivered certainty. Inside the turret, the optical sights revealed a different dimension of German intent. The clarity of the TZF-12A, its crisp reticle and finely ground lenses, outperformed anything in the American arsenal. Even when the platform shifted slightly, the image remained stable, offering the kind of confidence that allowed German gunners to exploit the full reach of their weapon. Test crews, accustomed to Shermans whose optics were functional but unremarkable, gave grudging nods. "They built this part right," one driver remarked, a simple acknowledgement that needed no further explanation. On the firing line, the Panther appeared every bit the predator German doctrine had imagined, precise, poised, and unmistakably lethal. Its numbers impressed, its behavior impressed. For a moment, the myth felt tangible. But away from the range, back in the maintenance sheds and on the rough ground behind the proving fields, a different ledger was taking shape. American engineers began recording the hours spent adjusting, repairing, and coaxing the machine forward. With each kilometer driven, the maintenance requirements rose sharply, outpacing anything expected of a frontline vehicle. The Maybach engine demanded attention in short intervals. Lubrication points reached into the dozens. And beneath the hull, the interleaved suspension, so smooth in motion, revealed its inherent burden. Mud packed itself between the wheels. Twigs and stones wedged into crevices no mechanic could reach without partial disassembly. What had looked elegant under ideal conditions became laborious under realistic ones. These observations were not new. Reports from the Eastern Front had already hinted at the problem: frozen mud that locked the road wheels, debris that seized moving parts, and crews who found themselves fighting not only the enemy, but the very machine entrusted to protect them. At Aberdeen, the pattern repeated with unsettling fidelity. Then came the testimony from captured German tankers, men who had served in Panthers across France, Poland, and the Baltics. Their reflections were consistent. "The tank was deadly," one explained, "but only when it moved." In that simple phrase lay the Panther's paradox. Its lethality depended on mobility, yet its mobility depended on conditions the war no longer offered. The engineers compiling their notes understood the implication. A weapon built on expectations of perfect terrain, perfect maintenance, perfect logistics, rarely survives the imperfections of war. And as they prepared the Panther for its next set of trials, they sensed that further revelations waited just beyond the horizon, where performance on paper would again collide with the realities of the field. With each new day at Aberdeen, the sounds emanating from the Panther began to change. What had first been a deep, confident hum gradually shifted into something sharper, more uneven, an undertone of mechanical discomfort that grew harder to ignore. Drivers reported subtle grinding during turns, a faint clatter when the vehicle reversed, and a low groan that followed acceleration like an echo struggling to keep pace. No single noise amounted to failure, yet together they formed a pattern that unsettled even the most optimistic observers. A machine this new should not already sound tired. The engineers focused quickly on the final drives, the compact gear assemblies tasked with translating engine power into controlled motion. German designers had forced enormous torque through a system never intended to bear such load, a decision rooted in necessity rather than prudence. The Panther's weight, more than 45 tons in later variants, had outgrown the limits of its own mechanical inheritance. What had begun as a medium T. Ink on the drawing board had become something much heavier in reality, and the final drives now labored under pressures that deepened with every kilometer. When the housing was opened after a series of test runs, the wear patterns told the story plainly. The gears were fighting a losing battle. American officers noted the irony. Germany had built a tank whose gun and armor seemed ready for the conflicts of the coming decades, but whose drivetrain remained anchored to older assumptions. The imbalance was almost philosophical, an expression of a nation that had pursued battlefield dominance while overlooking the mundane requirements of endurance. Interviews with captured German officers only reinforced this view. One, speaking with quiet candor, admitted, "We overbuilt the gun and the armor. We underbuilt everything else." His words carried neither bitterness nor pride, only recognition of a truth he had learned too late to change. At Aberdeen, that truth manifested itself step by gradual step. The Panther's test logs filled with notes documenting rising noise levels, elevated temperatures, and small but accumulating deformations in the load-bearing components. The suspension, once admired for its smooth ride, now revealed bushings and bearings wearing faster than expected. The gearbox delivered its power unevenly under strain. Even the tracks, broad and forgiving, showed accelerated fatigue when pushed across the proving ground's brutal testing lanes. Nothing failed catastrophically, but nothing held comfortably either. Quietly, American analysts began drafting their conclusions. The Panther, they wrote, had been engineered for victory, not longevity. It was a weapon designed to achieve dominance quickly, to shape battles decisively, and to intimidate opponents through the sheer force of its presence. But war rarely offers perfect terrain, perfect logistics, or perfect timing. A tank that demanded all three asked for more than the battlefield could reliably provide. Each kilometer at Aberdeen revealed a new strain point, as if the machine itself resisted the demands placed upon it. Beneath the heavy plates and sloped armor, the Panther was waging its own internal struggle, one that no crew could fully see, and no amount of battlefield bravery could overcome. For in engineering, every decision is a compromise, and in war, every compromise becomes a vulnerability. Ahead lay the moment when those vulnerabilities would cease to whisper and begin to speak in unmistakable terms. The next phase of testing at Aberdeen would be decisive. Engineers resolved to move beyond controlled demonstrations and subject the Panther to the conditions it would have faced in war. Long distances, uneven terrain, and the relentless pace demanded of a frontline armored force. Their goal was simple, almost clinical, to push the machine to its absolute operational limits and measure not what it could do briefly, but what it could sustain. For the first time, the Panther would be tested not as an idea, not as an instrument of theoretical superiority, but as a machine bound by physics, wear, and time. They began with endurance routes cut through wooded ground, where roots twisted beneath the soil and shadows fractured the landscape. In short bursts, the Panther performed with admirable agility. Its broad tracks floated across soft mud that would have troubled lighter vehicles, and its suspension absorbed shock with a composure rarely seen in wartime armor. Drivers noted how responsive the controls felt, how easily the engine delivered power when the vehicle climbed steep grades or pivoted between narrow stands of trees. In moments like these, the engineers glimpsed why the tank had earned its battlefield reputation. The Panther was not simply powerful, it was poised. Yet endurance trials are indifferent to elegance. As the distances lengthened, the machine's internal tensions began to surface. On extended climbs, the final drive casing transmitted vibrations strong enough to rattle tools inside the hull. At sustained speeds, the noise grew from a steady hum into a deep, grinding resonance that reverberated through the chassis. These were not the isolated symptoms of a single component out of alignment. They were signs of a system under strain, of gears and bearings forced to negotiate loads well beyond their intended tolerances. Temperature readings told the same story. During prolonged operation, the final drive overheated with alarming consistency, even when ambient conditions were cool. Lubricants thinned too quickly. Surfaces that should have glided against one another began to scrape. The engineers had seen these patterns before in other vehicles, but never so soon and never with such clarity. Heat, vibration, and uneven stress were converging, revealing a structural imbalance at the heart of the Panther's design. To contextualize their findings, analysis teams compared the Panther's drivetrain to that of the American Sherman, a tank often seen criticized for its modest firepower and plain engineering. But on paper, and more importantly in practice, the Sherman's final drive was a lesson in disciplined restraint. It was simpler, sturdier, built with wider tolerances, and designed with the expectation that field repairs would be frequent and urgent. Its components were not elegant, but they were resilient. They forgave mistakes. They endured dust, mud, cold, and inexperience. In strategic terms, this mattered more than brilliance. It meant the Sherman could outlast conditions the Panther could only survive briefly. The contrast was unmistakable. German engineers had optimized the Panther for tactical superiority, sharp engagements, controlled environments, brief displays of overwhelming force. They had built a machine that excelled in the narrow band of circumstances where terrain, maintenance, and crew experience aligned in its favor. But war rarely aligns with ambition. In the long arcs of operational movement, in the exhausting kilometers that stretch between battles, endurance becomes the truest measure of a tank's worth. As the Panther wound its way through the proving ground on the final day of testing, dust trailing behind it like a fading signature, the metaphor became impossible to ignore. The tank moved with the speed and grace of a champion sprinter, powerful and undeniable in short distances, yet visibly strained when forced into the rhythm of a marathon it had not been built to run. Every kilometer amplified the same quiet truth: brilliance without durability is a fragile inheritance. And just beyond these tests, the engineers prepared for the trial that would decide everything, when the Panther would no longer struggle but finally break. As the Aberdeen tests deepened, the Panther began to reveal not only the intentions of its designers, but the condition of the nation that had produced it. What first appeared to be a collection of isolated mechanical flaws soon formed a pattern, one that pointed far beyond gears and bearings. Beneath the tank's sloped armor lay a contradiction that no engineering brilliance could conceal. The Panther was a machine conceived in ambition but born into scarcity, shaped by a war economy collapsing under its own weight. German design philosophy had demanded precision. The Panther's critical components, its final drives, its bearings, its gear assemblies, were meant to be machined to narrow tolerances using high-grade alloys. In 1942, perhaps even in early 1943, those specifications were attainable. But by 1944, the realities of strategic bombing, dwindling resources, and an overstretched industrial base forced compromises that crept invisibly into every tank that left the factory floor. The Panther's complexity did not diminish as the war worsened. Its material quality did. American metallurgists at Aberdeen, trained to notice the subtle fingerprints of high-performance steel, immediately sensed something amiss. Samples taken from gears and housings revealed inconsistent hardness. Small inclusions, microscopic pockets of impurities, ran through components that should have been uniform. Some metals, when stress-tested, fractured along grain structures that hinted at hurried production or unreliable alloy mixtures. These were not simply manufacturing flaws. They were signs of a country running out of what its own designs required. The deeper the analysis went, the clearer the story became. Critical parts that once relied on molybdenum, nickel, or vanadium had been reformulated with inferior substitutes. Bearings built to endure thousands of kilometers now showed accelerated wear after only a fraction of that distance. Even the final drive housings, already the Panther's most vulnerable point, were cast from steels whose brittleness verged on the dangerous. A tank designed for precision had been constructed from compromise. The impact on performance grew measurable with each hour of testing. Vibration increased not because of driver error, but because the materials absorbing that vibration lacked resilience. Heat spiked not solely due to design, but because lubricants fought against surfaces never meant to grind so harshly against one another. Every list of observed faults traced back to the same root. The Panther had been engineered for a Germany that no longer existed. This became the pivot of the entire study. The moment engineers recognized that the Panther's flaws were not the result of miscalculation alone, but of a widening fracture between theory and reality. On paper, the tank's design approached brilliance. In the field, where metallurgical purity mattered as much as geometry, brilliance dissolved into fragility. Germany had crafted a weapon whose ambitions exceeded the nation's capacity to build it. American officers, reading the metallurgical reports alongside the mechanical logs, understood the historical significance. The Panther was not simply a tank. It was a reflection of a wartime society straining beyond its limits. As the Reich fought on multiple fronts, its factories were forced into a quiet war of substitution, replacing essential alloys with whatever the moment allowed, hoping the differences would remain invisible long enough to matter. But nothing remains invisible beneath the demands of continuous operation. Every kilometer widened the gulf between what the Panther was intended to be and what it had become. The test crews could feel that divide in the controls, hear it in the grinding of the final drives, and read it in the fractures forming beneath polished steel surfaces. A machine, after all, is only as strong as the society that builds it. And the Panther, for all its design brilliance, carried within it the fractures of a nation being consumed by the very war it sought to dominate. What none of the observers knew, at least not yet, was that this tension between design and reality was approaching a breaking point, one that the next trial would bring into unmistakable focus. The long-distance evaluation began in the early light of a cool morning, when the proving ground was still quiet and the air carried the faint metallic scent of dew settling on machinery. The Panther rolled out first, its engine steady, its tracks leaving clean impressions in the damp soil. Engineers followed in jeeps, clipboards balanced on their knees, ready to record every sound and deviation. For the first hour, the tank behaved predictably, lumbering across open stretches, climbing small embankments, and settling into a rhythm that suggested the day might end uneventfully. But endurance trials rarely announce their turning points. They reveal themselves with sudden clarity. Near the 90-kilometer mark, drivers reported a deepening vibration beneath the hull, subtle at first, then growing into a palpable tremor that rattled tools stored along the turret wall. The Panther pushed on, its engine still confident, but something in its movement had changed. The tank no longer glided, it labored. With each kilometer, the vibrations intensified, building like pressure in an unseen chamber. At roughly 150 kilometers, the machine shuddered sharply, lurched forward once, and then fell silent. The engine continued running, but the tracks no longer moved. A single, unsettling truth settled over the observing crews. The Panther had reached its limit. Smoke curled from the final drive housing, thin at first, then thickening into a gray plume that rose through the autumn air. Mechanics rushed forward, extinguishers in hand, waiting for the metal to cool before opening the casing. When they finally removed the access plate, the extent of the failure became impossible to ignore. Gear teeth lay fractured, some sheared cleanly, others twisted into jagged shapes that spoke of violent internal force. Bearings had overheated, leaving behind scorched residue where clean surfaces should have been. And across the assembly, warping was visible, steel softened not by design flaws alone, but by metallurgy unable to withstand the sustained punishment of movement. The engineers began their calculations with a quiet, deliberate precision. They cross-referenced test logs, measured wear patterns, and compared metallurgical samples taken before and after the trial. When the figures were finally compiled, the conclusion was stark. Under ideal circumstances, cool weather, careful driving, skilled maintenance, the Panther's final drives could be expected to endure approximately 150 to 200 kilometers before catastrophic failure. The number hung in the air with a weight disproportionate to its simplicity. Here was a tank celebrated for its battlefield performance, yet its operational lifespan could be measured in the distance between two rural towns. The implications were far-reaching. German armored battalions routinely repositioned over distances exceeding that threshold in a single week of campaigning. Retreats, especially those conducted in haste, demanded even greater mobility. Allied vehicles, such as the Sherman, often traveled hundreds of kilometers in the course of an offensive without requiring major drivetrain replacements. But for the Panther, such distances represented mechanical death sentences. The engineers at Aberdeen saw the truth clearly. The tank's design allowed it to dominate in tactical encounters, but its endurance was insufficient for the operational realities of modern war. Captured German reports reinforced the conclusion with sobering clarity. In France, Panthers abandoned along retreat routes showed identical patterns of failure. Final drives seized, bearings melted, gears torn apart by forces they were never meant to endure. On the Eastern Front, where distances stretched beyond anything in Western Europe, Panther units often cannibalized their own vehicles simply to keep a fraction of the battalion moving. The same failures that unfolded on American soil had occurred in the mud of Belarus, the forests of Poland, and the fields of UK. The Aberdeen tests had not uncovered a unique weakness. They had confirmed a universal one. And so the contradiction stood exposed. The tank that had terrified Allied crews, whose gun commanded distance and whose armor deflected blows meant to destroy it, could not reliably survive the journey to the battlefield where its strengths mattered. Its engineering brilliance had set expectations the machine itself could not sustain. As the Panther sat silent on the proving ground, its tracks cooling and its internal components ruined beyond repair, the observers knew that the next phase of testing would move beyond diagnosis. The question was no longer whether the Panther could fail. It was what such failure revealed about the war that had produced it, and about the machines that still waited to be tested. When the Aberdeen findings were compiled into their final brief, the tone was restrained, almost clinical. Yet beneath the measured language lay a verdict that cut directly through the mythology surrounding Germany's most celebrated tank. The Panther, the report concluded, was tactically formidable, its gun exceptional, its armor advanced, its optics unmatched. But strategically it was compromised at a fundamental level. No formation could rely on a machine that faltered before reaching the battlefield. No operational plan could rest upon mobility measured in tens of kilometers. And no army, however skilled its crews, could overcome a vehicle designed for victories it lacked the endurance to reach. These conclusions traveled quickly through the armored command, reshaping assumptions that had guided American planning for months. Frontline officers, long puzzled by the number of intact Panthers found along retreat routes in France, now understood the reason. These tanks had not been lost in the chaos of withdrawal. They had succumbed to their own internal limits. What appeared at first to be forced abandonment was, in truth, predictable mechanical fate. The Panther had not been defeated by Allied firepower. It had been defeated by distance. Reliability now emerged as the deciding factor in evaluating battlefield power. A weapon, no matter how lethal in controlled engagements, could not influence a campaign if it could not reach the fight, remain there, and continue operating under pressure. Tactical brilliance collapsed when paired with operational fragility, and so a quiet recalibration began, one that placed endurance, repairability, and logistical harmony at the center of a tank's true worth. It was within this context that the Sherman, so often dismissed as inferior, began to appear in a different light. The more the Panther was studied, the more the Sherman's strengths came into focus. Its mechanics were straightforward, its components resilient, and its maintenance tasks achievable by crews with modest training. It was built for repetition, to travel long distances, to survive harsh conditions, and to return to battle after quick field repairs. Its gun lacked the Panther's reach, but its reliability compensated in ways that strategically mattered more. In the calculus of war, the Sherman endured. Production statistics deepened the contrast. Germany could manufacture Panthers only in limited numbers, slowed by shortages, complexity, and the precision demanded by their design. Each one represented considerable industrial strain, a single tank consuming disproportionate resources. The United States, by contrast, produced Shermans in vast quantities, each built more quickly, more consistently, and with fewer material demands. Where Germany constructed a masterpiece that faltered, America built fleets that persisted. The outcome was not a surprise, but an equation. Machines that can be made, moved, and maintained in great numbers inevitably shape the battlefield more than machines that promise perfection but deliver uncertainty. As these realities spread through command channels, the Panther's reputation began to fracture. The tank that had loomed so large in Allied imagination now stood revealed as something more nuanced, brilliant in conception, compromised in execution, undermined by the pressures of a war Germany could not sustain. Its strengths were real, but they lived inside a machine whose weaknesses were unavoidable. And once those weaknesses were known, they changed everything about how the Panther was understood. In this shift lay a deeper lesson. Performance, the engineers noted, is not the same as power. A machine that delivers extraordinary results in isolated moments does not shape history unless it can deliver them again and again, across terrain, weather, logistics, and time. Endurance, the quiet, unglamorous virtue, defines the true potency of a weapon. It determines whether brilliance becomes influence, or whether it remains an impressive but fleeting demonstration. As Aberdeen prepared its next series of evaluations, the shift in perspective was complete. The Panther would still be respected. It would still be studied, but it would no longer be feared in the way it once had been. For the test crews understood that the tank's greatest adversary had never been the Sherman, nor Allied air power, nor the weight of numbers massed against it. The Panther's greatest adversary had been the truth of its own design, and the war that exposed it. What remained was to examine how this truth echoed across the rest of German armor, and whether the lessons drawn from one tank could illuminate the fate of an entire doctrine. As the final reports from Aberdeen circulated through the U.S. Army's armored divisions, a deeper analysis began to take shape, one that looked beyond the Panther itself and toward the philosophies that had produced it. Officers, engineers, and tacticians met around long tables scattered with blueprints, metallurgical samples, and field observations. Their task was no longer to judge a single tank, but to understand how two nations, approaching the same problem of mechanized warfare, had arrived at such different conclusions. In this contrast lay the true lesson of the Panther, and perhaps the clearest window into the doctrines driving the conflict. German design philosophy revealed itself plainly in the Panther, a belief that battlefield dominance came from superior geometry, superior penetration, and superior precision. Every component reflected an engineer's desire to maximize performance at the decisive moment, the single perfect shot that would destroy an enemy before it could respond. This thinking had deep roots in German military culture, which valued tactical excellence and technical refinement almost as moral virtues. To the designers of the Panther, the ideal tank was one that could outperform its opponent in direct combat, even if achieving that ideal required extraordinary complexity. American doctrine had followed a different path. The Sherman, often criticized for its modest armor and comparatively shorter-range gun, embodied priorities shaped by geography, industrial capacity, and strategic necessity. The United States fought a global war that hinged on logistics. Tanks needed to cross oceans, traverse continents, and remain operational for months at a time. Reliability was not an accessory, it was the heart of the machine. A tank that could be repaired quickly, driven repeatedly, and produced in immense numbers offered an advantage no thickness of armor could replace. In this sense, the Sherman's greatest strength was quiet, almost understated. It was present. It arrived where it was needed, and it stayed there. As analysts compared the two machines, the contrast sharpened. Germany had optimized for the perfect shot. The United States had optimized for the sustained campaign. One defined power as precision, the other defined power as endurance. The Panther's battlefield lethality was undeniable, but its operational fragility nullified that advantage long before most engagements began. In meetings at Aberdeen, an engineer summarized the point with disarming clarity. "A tank that breaks down before battle never fires a shot." The room fell silent. The observation was simple, but it cut to the heart of the matter. A weapon's value is not measured by what it might accomplish under ideal conditions, but by what it consistently delivers under real ones. The Panther's performance in Allied hands reinforced this conclusion. When it ran, it impressed. Its gun struck targets with the authority of a machine built for dominance. Its armor, angled with revolutionary foresight, shrugged off incoming fire that would have crippled lesser vehicles. Its optics allowed gunners to see with clarity many Allied crews envied. But each hour of operation built toward a moment of inevitable interruption. A vibration, a spike in heat, a fracture hidden beneath the surface. Brilliance was always accompanied by brittleness. And in war, brittleness is a liability no amount of tactical brilliance can fully conceal. This realization marked a turning point in Allied understanding of German armored warfare. For years, German tanks had been interpreted through the lens of fear and respect, their battlefield performance shaping the narrative of technological superiority. The Panther now forced a reassessment. It revealed that German doctrine had produced machines of exceptional capability but limited practicality, weapons optimized for specific moments rather than prolonged campaigns. The flaw was not merely mechanical, it was conceptual. In seeking mastery at the point of contact, Germany had overlooked the vast and grinding machinery of operational warfare. The marches, the retreats, the resupply lines, the maintenance cycles. The Panther's failure was therefore not an anomaly but a symptom. With this insight, the engineers at Aberdeen began preparing their final evaluation. It would not diminish the Panther's achievements, nor overlook the innovation embodied in its design. Instead, it would present a balanced judgment. The Panther was lethal but unsustainable. It was a triumph of engineering vision compromised by industrial strain and strategic misalignment. A tank built to win duels had been asked to win a war, and that was a burden it could not carry. As the final documents neared completion, the engineers understood that their work had revealed more than the truth of a single machine. It had illuminated the divergent paths of two nations, and the quiet power of simplicity in a conflict defined by complexity. Ahead lay the conclusion, where this lesson would be framed not merely as analysis, but as the enduring legacy of the Panther itself. By the final winter of the war, German armored units moved not with confidence, but with resignation. Reports from the Eastern Front and the ruins of Western Europe described Panthers left smoldering along roadsides, not because of Allied fire, but because their own machinery had given out under the strain of retreat. In battalion diaries, commanders recorded with increasing frustration that a third, sometimes half of their Panthers were lost to breakdowns before ever encountering the enemy. What Aberdeen had uncovered in controlled trials now unfolded across entire theaters of war. The tank's greatest liabilities emerged long before the first shot was fired. For the crews, this was not merely an operational concern, but a daily reality. Panther units joked grimly that the Panther kills more of us than the enemy, a line delivered with the dry fatalism of soldiers who understood they were trapped inside a contradiction. They admired the tank's firepower, its armor, its promise. They feared its fragility, its unpredictability, its appetite for repairs that could not be supplied. The humor was a shield, a way to endure the knowledge that their survival depended as much on mechanical fortune as on tactical skill. In these frontline remarks, American intelligence found not irony but inevitability, the natural consequence of sending a precision instrument into a world that demanded something rugged and enduring instead. To analysts in Washington and at Aberdeen, the Panther came to symbolize more than a vehicle. It revealed the nature of the war Germany had prepared for and the war it actually faced. The Panther had been built for a conflict defined by speed, decisive engagements, and tactical overmatch, a vision of mechanized warfare shaped by the early victories of 1940 and the opening months of Operation Barbarossa. In that imagined war, the Panther made sense. Its gun ensured dominance in duels. Its armor provided immunity from frontal hits. Its optics allowed for superior long-range engagements. It was a tank designed for clarity, a battlefield where the first, best shot determined the outcome. But the war that consumed Europe by 1943 bore little resemblance to this vision. The conflict had become industrial, attritional, and geographically unforgiving. It demanded reliability over brilliance, production volume over technical refinement, and mechanical endurance over delicate advantage. The Panther, with its intricate suspension, sensitive drivetrain, and dependence on high-quality alloys that Germany could no longer produce, belonged to a world that had already disappeared. Each breakdown in the field was not merely a mechanical failure. It was a collision between doctrine and reality. The final drive became the symbol of this collapse. In theory, it was compact, powerful, and efficient. In practice, it was overstressed from the moment the tank entered production. Panther crews learned to listen for its warning signs: the rising whine during acceleration, the shudder during turns, the heat that radiated even in winter cold. They knew that once those symptoms emerged, the tank's remaining lifespan might be measured not in days, but in hours. When Allied forces advanced through France, they found Panthers abandoned with their engines intact, their guns unused, their armor unscarred, vehicles defeated not by the enemy, but by the weight of the design assumptions they carried. American intelligence officers studying these patterns recognized a broader truth. The Panther had not simply failed mechanically, it had failed strategically. Germany had invested engineering brilliance into a machine that required a stable, resource-rich industrial base to sustain it. But by 1944, Germany possessed neither the resources nor the time to support such a vehicle. Every Panther delivered to the front represented a gamble that conditions would match the idealized scenarios its designers had envisioned. Those conditions never returned. By 1945, the consequences of this mismatch were stark. German armored doctrine, once envied for its innovation, now revealed its dependence on weapons that could not survive the demands of a long war. The Panther, for all its strengths, illuminated the limits of a strategy that sought victory through tactical superiority while neglecting the deeper structures of endure. Ants, fuel, spare parts, production resilience, and the capacity for sustained movement across a continent at war. In the end, the Panther did not collapse because it was poorly conceived. It collapsed because it was conceived for a world that no longer existed. The machine remained faithful to its design philosophy until the end. The philosophy, not the machine, was what failed. Even great machines falter when built upon a foundation of miscalculated reality. And as the engineers prepared to draft the final conclusions of the Aberdeen trials, they understood that one final step remained, to place the Panther at last in its true historical context. In the years following the war, as new armored programs began to take shape across the United States, the data collected from the Aberdeen Panther tests found a second life. Engineers who had once stood beside the tank on muddy proving grounds now sat in quiet offices, translating their field observations into design principles that would shape the next generation of American armor. Manuals, technical reports, and lecture notes all repeated a single theme, one distilled from the Panther's rise and collapse. Reliability must precede sophistication. No elegance of design, no superiority of firepower could compensate for a machine that faltered under the simplest demands of movement. The Panther's mechanical fragility became a case study taught across engineering schools and military academies for decades. Students learned how overstressed components, insufficient metallurgical resources, and overambitious tolerances combined into a predictable chain of failure. The final drive, the compact, overstressed heart of the Panther's mobility, emerged as the central exhibit in this lesson. Charts displayed wear patterns, temperature curves, and failure points. Diagrams traced how microscopic impurities in steel propagated into fractures under repeated strain. What had once been cutting-edge German engineering served now as a cautionary tale. Complexity cannot redeem a weak foundation. American officers reviewing the wartime experience came to view the Panther not as a triumph of German ingenuity, but as a warning about unchecked ambition. Germany had sought tactical perfection at the expense of operational reality. It had designed a weapon that assumed ideal conditions, infinite materials, and uninterrupted maintenance, assumptions that no nation, especially one fighting on multiple collapsing fronts, could hope to sustain. This contrast exposed the philosophical divide between two approaches to mechanized war. The Panther expressed the desire to dominate, the Sherman expressed the need to endure. History showed clearly which of the two mattered more. Yet none of this diminished the battlefield terror the Panther once inspired. Veterans who had faced it spoke with genuine respect for its gun, its armor, and the moments when its mechanical strengths aligned long enough to create true danger. The tank's silhouette, low, angled, predatory, remained etched into the memory of those who had fought against it. But legacy is not built solely on fear. It is shaped by outcomes. And the outcome of the Panther's story was determined not by what it could do briefly, but by what it failed to do consistently. The failure at 150 kilometers became more than a number. It became a symbol of strategic overreach. It illustrated the limits of a nation attempting to engineer solutions to problems that required industrial answers. No matter how advanced the Panther appeared on paper, no matter how powerful its gun or innovative its armor, it could not escape the consequences of a war economy stretched beyond every threshold of sustainability. Its brilliance became an indictment, its strengths reminders of what Germany hoped to achieve rather than what it could maintain. In this way, the Panther mirrored the trajectory of the Reich itself, ambitious, formidable, and ultimately undone by realities it refused to acknowledge. This was the lesson that found its way into post-war design rooms. As American engineers began sketching the outlines of future tanks, they returned repeatedly to the same insight. Machines tell truths their designers never intended. They expose the gap between theory and practice, between ambition and capability, between what a nation dreams of building and what its factories can actually sustain. The Panther's truth was unmistakable. It taught the United States that battlefield power begins long before the first shot is fired. With logistics, metallurgy, manufacturability, and the quiet discipline of designing not for perfection, but for endurance. And as the post-war programs advanced toward prototypes and production, another realization settled quietly across the engineering corps. One final evaluation remained, the summation of everything the Panther had revealed. The story of German armor was nearing its conclusion, but its consequences were just beginning to shape the future. Decades after the war, the Panther's legacy became a subject of enduring debate among historians, engineers, and armored theorists. Some argued that it had been ahead of its time, a glimpse of the future constrained by the limitations of its present. Others insisted it had been fundamentally unsuited to the war it was built to fight, a machine whose ambitions collided fatally with the brutal arithmetic of attrition. Both views contained truth, and neither fully resolved the paradox at the heart of the Panther's story. What could not be denied was the influence of its silhouette. Long after the last wartime Panther had rusted into the soil of Europe, its form, low, angular, and unmistakably purposeful, echoed across the design boards of the early Cold War. Tanks such as the French AMX-50, the Soviet T-54's derivative proposals, and even American experimental models bore hints of the Panther's geometric clarity. Its sloped armor, once a revolutionary answer to the T-34, became standard practice across the world's armored forces. In that sense, the Panther succeeded not as a machine of war, but as an idea, one that shaped the outlines of tanks for generations. Yet if its silhouette endured, many of its mechanical choices did not. No nation attempted to replicate the Panther's interleaved road wheels or its compact, overstressed final drives. These components, so refined in theory, had proven too sensitive, too fragile, too demanding for the realities of sustained combat. Instead, designers adopted the Panther as a cautionary reference, a reminder that even the most impressive battlefield performance can be undone by the simplest failure of endurance. Engineering journals commonly paired the tank's famed gun and armor with diagrams of its fractured drivetrain, placing brilliance and vulnerability side by side as a lesson in balance. This shift reflected a broader transformation in armored doctrine worldwide. By the 1950s, militaries had come to understand that tanks must be maintainable not only in workshops, but under fire, not only by engineers but by crews exhausted, freezing, and pressed for time. Mobility had to be constant. Reliability had to be assumed. And survivability had to extend beyond armor thickness to include the ability to function day after day in conditions no drawing board could fully predict. The Panther had demonstrated, with striking clarity, that a tank unable to move was a tank unable to fight, and that no amount of firepower could compensate for a single mechanical flaw located deep within the vehicle's core. Thus the Panther entered history as a paradox, admired for its innovation, feared for its firepower, and remembered for the fragility that defined its fate. It was a tank of contradictions, one that combined elegance with impracticality, ambition with oversight, brilliance with brittleness. Its story could not be told solely through the lens of what it accomplished. It had to be understood through the context of what it could not sustain. For historians, this duality became central to its legacy. The Panther's successes were genuine, but so were its failures, and the two could never be separated. To praise its engineering without acknowledging its limitations was to misunderstand the machine entirely. To condemn it outright was to overlook the ways it reshaped armored warfare for decades. The Panther lived between these extremes, occupying a place where admiration coexisted with caution. In the end, history tends to remember not the machines that shine briefly, nor the ones that inspire awe in isolation, but the machines that endure, those that survive the march, the mud, the cold, the distance, and the demands of a war that offers no ideal conditions. The Panther, for all its brilliance, was not one of them. And so its legacy stands as both inspiration and warning, a reminder that great machines are forged not only in moments of genius, but in the relentless test of reality that follows. When the Aberdeen engineers assembled their concluding report, the document carried none of the drama that had surrounded the Panther on the battlefield. Its tone was measured, its analysis precise, its verdict unmistakable. The Panther, they wrote, was a powerful gun mounted on an unreliable chassis, a weapon whose strengths were undeniable, but whose weaknesses determined its fate. In the hierarchy of modern armored warfare, mobility was life, and the Panther's final drive had placed an upper limit on that life that no crew, however skilled, could overcome. The report described the final drive with clinical finality, an overstressed assembly whose operational lifespan averaged just 150 kilometers under favorable conditions. In a war defined by constant movement, advances, retreats, redeployments, and the ceaseless demands of logistics, this was not merely a flaw. It was an unforgivable vulnerability. A tank that could not travel the distance required to reach its own battles could never shape those TT-less, no matter how formidable its gun, or how elegant its armor geometry. What defeated the Panther, the engineers concluded, was not Allied firepower nor tactical inferiority. It was the forces hidden within its own machinery, the heating, grinding, fracturing stresses that accumulated with every mile until one component failed, and the entire vehicle followed. The tank that had seemed invincible on paper and terrifying in first encounters was undone by the quiet mathematics of metal fatigue and mechanical imbalance. Its downfall had been engineered unknowingly by the very hands that crafted its brilliance. From this insight emerged a broader lesson, one that transcended the Panther itself. Perfection in one domain cannot compensate for fragility in another. A tank that excels at the moment of engagement but cannot endure the journey to that moment is not a war winner, but a war casualty waiting to occur. The Panther embodied this paradox with striking clarity, extraordinary in the instant, unsustainable over time. War, the engineers reflected, does not reward brilliance. It rewards endurance, the ability to persist through distance, attrition, and the unglamorous demands of maintenance and supply. In this light, the abandoned Panther on the French roadside, so pristine, so mysterious, so haunting in its stillness, suddenly made perfect sense. Its crew had not fled in panic. They had simply reached the mechanical limit the tank had always carried within it. And so the final line of the report, though never written explicitly, echoed in every conclusion drawn from the data. They feared the Panther once, until they discovered why its crews walked away.